So let us write down the pseudo algorithm for this Thomas algorithm. So what we will do, first we will, the step one is that note down vector D, U and L. Second step is that assign alpha 1 is equal to D1 and beta 1 is equal to B1. Third step is for I going from 1 to n minus 1, to going from 2 to n minus 1, calculate alpha I as di minus li upon alpha I minus 1 ui minus 1 and beta I is equal to bi minus li upon alpha I minus 1 beta I minus 1. The fourth step is find alpha n as dn minus ln upon alpha n minus 1 un minus 1. The fifth step will be and also find out beta n as bn minus ln upon alpha n minus 1 beta n minus 1. Find xn is equal to beta n minus alpha n. Then the sixth step will be I going from n minus 1 till 1, calculate xn as beta n un minus xn plus 1, sorry, this is xi is equal to beta I minus ui xi plus 1 upon alpha y. This way we will calculate the vector x using Thomas algorithm. So I will give you one example. So let us see example. So example is that I have minus 2 1 0 0 1 minus 4 1 0 0 1 minus 4 1 0 0 1 minus 2, and then this is having x1 x2 x3 x4, and on the right hand side we have 3 1 2 minus 2. So my vector L is nothing but L1 is 0 0 1 1 minus 2, D is minus 2 minus 4 minus 4 minus 2, and U is 1 1 1 0 because the last element, this is un and this is L1. So my alpha 1 is nothing but D1 which is minus 2, beta 1 is nothing but B1 which is 3. Here the vector V is 3 1 2 minus 2. Now if I calculate the alpha 2, that will be 1 minus li upon alpha I is 1 upon minus 2 . into qi minus 1, and that will be ui minus 1 will give me 1. So this is nothing but, this is alpha 2 is di, so this is minus 4. So this is nothing but minus 4 plus 1 by 2 is equal to minus 3.5. Beta 2 is nothing but beta I, that is 1 minus 1 upon minus 2 into 3. So this becomes 1 minus 1 plus 3 by 2 is nothing but 2.5. Similarly, I will have alpha 3, that will come out to be minus 3.7142. Beta 3 will come out to be 2.714, and alpha 4 will become minus 1.75, and beta 4 will become minus 1.26. Now if I do the back calculation, then my x4 will be minus 1.26 upon minus 1.75, that is 0.733. x3 will be 2.714 minus 1 multiplied 0.733 divided by alpha 3, which is nothing but minus 3.7142, and that will give me minus 0.5333. Similarly, x2 will come out to be minus 0.86665, and x1 will come out to be, similarly we can calculate the x1 also. I have not done the calculation for x1, but you can do that. So this is how we will basically calculate the solution of ax is equal to b with the direct solver or the direct algorithm, that is Thomas algorithm. So let me give you the summary of this algorithm. So this algorithm is applied when the bandwidth of the banded matrix is 3. That means we have a tridiagonal matrix. In the tridiagonal matrix, we have the main diagonal D. We have the upper diagonal adjacent to the main diagonal known as vector u, and the lower diagonal adjacent to the main diagonal, that will be given as vector L. And in the right hand side, we will have the vector B. Then we will define two new vectors. Those vectors will be alpha and beta, and the value of alpha 1 will be equal to d1, and the value of beta 1 will be equal to b1. And for I going from 2 to n minus 1, we will define alpha I as di minus li upon alpha I minus 1 times ui minus 1, and we will define beta I as bi minus li upon alpha I minus 1 times bi minus 1. So in that way we have gone from 1 to n minus 1. For nth term, we will define alpha n as dn minus ln upon alpha n minus 1 times un minus 1, and then we will define beta n as bn minus ln upon alpha n minus 1 times beta n minus 1. So this is basically the same formula. We can say that for I going from 2 to n, we are calculating the alpha n and beta n. Now for the last row, since we do not have the un, then we can directly calculate the xn as beta n upon alpha n. And for rest of the element of the vector x coming starting from I is equal to n minus 1 to 1, we can calculate xn as beta n minus un times xn plus 1 upon alpha n. So this is the Thomas algorithm in summary. In the next video, we will talk about more direct matrix solvers or more direct linear equation system of linear equation solver algorithms. Thank you.